Hi, we're Team Rexus and this is our rover for the University Rover Challenge 2023. Team Rexus features mechanical, electrical, autonomous and science subsystems, working on various projects like chassis, drivetrain, robotic arm, onboard lab and autonomous navigation. These are integrated together to solve the 4 problem statements as defined by the competition guidelines.
Our rover features a welded aluminum tube chassis comprising of push-rod suspension and custom mount for the laboratory and the arm. The wheels were designed using topographical optimization and are a combination of PLA and TPU rubber light, with a maximum traversing angle of 25 degrees tested. Custom motor mounts take loading of the motor shafts and help in power transmission from planetary gearbox to the wheels. The electric housing features removable sliding battery panels actively cooled using fans with a separate cool compartment for the drivetrain and robotic arm components.
The drivetrain of the rover consists of a 24-volt brushed DC motor in combination with a 24-volt 30-ampere-hour battery. The rover is controlled by using onboard Raspberry Pis. Smart motor drivers power the drive system with magnetic absolute encoders providing positional and velocity data, which are used for closed-loop PID control. Custom motor driver circuit PCBs and a power distribution network PCB are being developed for cleaner and more reliant connections across systems. Onboard electronics use serial communication protocols, while the base station rover communication uses RF modules at short range and 11 dBi omnidirectional antenna in the 2.4 GHz frequency band, backed up by 900 MHz frequency LoRa module.
The 4th degree of freedom robotic arm comprises of 2 NEMA 34s and 2 NEMA 23 stepper motors. They were chosen due to the relatively low cost and high control of up to 40,000 steps per revolution. The aim of the robot is to replicate the shoulder, the elbow and the wrist of the human arm. Links are made of aluminum tubes and the joint interfaces are custom machined solid aluminum blocks. We are using planetary gearboxes for the NEMA motors on all of the joints as they provide minimum backlash. Different end effectors are currently under development, which allows us to turn hex keys, flip switches and actuate door handles. Control of the arm can be done both by inverse kinematics and also by a one-to-one physical twin which maps its position and velocity to that of the actual arm.
The science subsystem is equipped with multiple instruments and sensors for detecting the presence of extinct and extant life. Soil is gathered from below the surface using a scooper attached to the robotic arm of the rover. This is fed into a hopper and mixing chamber which distributes the soil into our 2 main instruments, an absorption spectrophotometer and a digital microscope. The spectrophotometer is used for 2 chemical assays which detect the microbial enzyme activity and quantify the amount of protein present in the soil. Peristaltic pumps are used to deliver accurate and precise amounts of reagent and soil suspension into each sample. The microscope is used for determining the mineral composition of the soil, as well as identifying any microfossils left by extinct life. The onboard laboratory also has a cache system, which keeps samples from each sample site and can dispense a high scientific value sample when it is chosen. There are also sensors that measure the temperature, humidity, pressure, ambient light, UV light, and soil NPK content, which are used to assess the habitability of each sample site.
The odometry system uses an IMU and depth cameras which constantly update a cost map. The global planner is used to find the minimum distance between given start and end GPS points, while the local planner gets the updated cost map and produces velocity commands which are sent to a move-based function which is used to move the rover. Kalman filters are being used to fuse the odometry data. We are using a ROS framework to run all our packages. We are currently integrating a LiDAR sensor as well as a GNSS sensor into our odometry system.